This is the first entry on a series of discussion videos on the topic of concavity and the second derivative test for relative extrema. Let us answer some exercise problems. For the first problem, it is asking us to identify the possible points of inflection of the graph of each function. So the functions are given below, a and b. So let us determine which of these are indeed points of inflection using a table of signs. And we should also determine the intervals on which the graph of the function is concave up or concave down. So for function a, if f of x is equal to x squared minus 3 all over x squared plus 1, to find the possible points of inflection, we should find the zeros of the function f, or the zeros of the second derivative of the function f. Of course, there are two ways to find possible points of inflection. You can, okay, so you can either solve for the zeros of its second derivative or the values of x in which the second derivative of x does not exist. But of course, we will see later on that the second derivative of x or the second derivative of f is defined for all values of x. So let us actually compute the second derivative of f. So the first derivative of f is given by, so by quotient rule, f prime of x is equal to 2x times x squared plus 1 minus 2x times x squared minus 3 all over the square of the denominator. If we simplify this expression, we find that f prime of x is equal to the following. So this is 4 all over x squared plus 1 squared 8x all over x squared plus 1 squared. Okay. So the second derivative of f is given by, again, another implementation of the quotient rule gives us 8 times x squared plus 1 squared minus 8x times 2 times x squared plus 1 times 2x all over the cube of x squared plus 1. Okay, we can factor out 8 and we can observe that x squared plus 1 is a common factor in the numerator and denominator. So we end up with x squared plus 1 minus 4x times, okay, so that's it, minus 4x squared squared plus 1 squared. So this is equal to um, negative 8 times 3x squared minus 1 all over 8x squared plus 1 squared. Finally, let us rewrite f double prime of x in a convenient form. Let us factor out 3 in the numerator. So we have x minus 1 over square root of 3 and x plus 1 over square root of 3. So as we can see, f double prime of x is defined everywhere, and its zeros are its zeros are the possible points of inflection of f. So those are given by the positive and uh, negative multiples of 1 over square root of 3. Okay, so from this we can construct the table of signs of f double prime. So we construct it like so. Now when x is less than 1 over square root of 3, obviously this factor is negative. This factor is negative. This factor is always positive. This factor is also always negative. However, this factor is also always negative whenever x is less than 1 over square, whenever x is less than negative 1 over square root of 3. So this factor is also negative. Therefore, as a function of a multiple of 3 negative factors, f double prime of x, when x is less than 1 over square root of 3, it's negative. Now, if x is less than 1 over square root of 3, but x is greater than negative 1 over square root of 3, then x plus 1 over square root of 3 is greater than 0, and x minus 1 over square root of 3 is less than 0. So this factor is positive, but this factor is negative. So f double prime of x is positive in this interval. And lastly, when x is greater than 1 over square root of 3, x minus 1 over square root of 3 greater than 0. Okay, so this factor is positive. This factor is also positive. So positive, positive times negative, all over positive is negative. Okay, so we see that as x passes through the point negative 1 over square root of 3 and positive 1 over square root of 3, f double prime of x changes its signs or changes its sign. Therefore, these 2 points are indeed points of inflections. Therefore, x equals positive negative 1 over square root of 3 are indeed points of inflections. Also, we can see from the table of signs that f of x is concave down on the following intervals from negative infinity to negative 1 over square root of 3 and 1 over square root of 3 to positive infinity. And f of x is concave up on the interval negative 1 over square root of 3 to 1 over square root of 3. Okay? That's how we answer that's how we answer for the first function. For the second function, I'll see you on the next discussion video.